We're going to revisit exercise 3 using the brute force substitution method, which involves having a known solution and then assuming that your second solution is some unknown function of x times the known solution. So this is how it's going to kick off. If you need to pause for a moment to verify that my calculations for y prime and y double prime are correct, feel free to go ahead and do that. But the idea is that I'm going to assume y sub 2 equals this function. I'm going to want to plug things back into the original differential equation. So I'll just go ahead and take the different derivatives, and I'm going to plug them in a moment. I do want to point out, though, that when you're doing this portion of things, we do need to, unlike before where I could kind of ignore the constants when I was integrating and stuff, these need to all be respected and taken care of because they all affects how this is going to work out. So here are my derivatives. I'm going to pause the video as I write the plug-in, but this expression is going to be plugged in for this. This will be plugged in over here. This will be plugged in here. And once I combine all like terms, what should happen is I should be left with a differential equation that has just u primes and u double primes. So let's see if that actually works out. I'm going to pause, and while the video is paused, I'll be substituting, distributing, and combining like terms. Pausing the video now. So this is my expression with all of its different equations plugged in. I distributed 6 each part of this. I'm going to look at all the terms that have a u on them. That's this guy, and this guy. They do combine to make 0. So I'm left with a 6ex over 3 u double prime. And then if I look at all those u prime terms, I'm going to be left with plus 5 e to the x over 3 u prime equals 0. So as promised, that u is gone. So I just have a u prime and u double prime. I'm going to replace the u double prime with a w prime. And I'm going to replace the u prime with a plain old w to make it look more like a first order differential equation where w prime is considered to be the derivative of w with respect to x. This is definitely a first order separable differential equation. To really emphasize that point, I'm going to rewrite that w prime as dw dx plus 5e to the x over 3w equals 0. I'm going to go ahead and separate these different variables and treat it like a separable differential equation. So when I do that, my goal is to get dw in the numerator, the dx in the numerator, get all the w's together, all the x's together. So let's start by dealing with this dw since it's already in the numerator. Divide everybody by w. So I'll end up with a 1 over w dw. And then let's get this function out of here. So I want the dx, I'll multiply everybody by dx. You end up getting the e to the x over 3's cancel, 5 over 6 dx equal to 0. If I integrate every part of this, now I'm at the point where we're starting to hone in that solution. I don't care about these extra constants that show up. They're not going to really affect things in this equation. So we're going to have the natural log of w plus 5, 6x equals some constant that I do not care about. If I want to do that thing where I exponentiate everything, I've got to get this natural log to be all by itself. So I'm going to have the natural log of w equaling negative 5, 6x plus that constant that I don't care about. You'll see why really in a second. We'll track it for now. And then, of course, to get this w by itself, I'm going to put everything to the e power. I'm just going to take it to a place that says w equals e to the negative 5, 6x plus a c, which would then become a c in front of this e, which I do not care about. We're not done yet, though, because I don't want to find w, I want to find u, but obviously I've left myself with no room to write. So I'm going to pause my video and delete all this stuff. So if you need to look over any of this work, you should definitely pause the screen yourself and kind of review what's going on here. Because in about 10 seconds, or no, less than that even, it's all going to be gone. I'm pausing my video now. And the deal was that w is really your u prime equaling e to the negative 5, 6x. And the u prime is the function of x. I'll integrate and integrate to figure out what u is. This is going to be its very own integral with a constant in front, and that constant in front I do not care about. So I'm just going to go ahead and say u equals some constant times this stuff. But of course, I wasn't trying to find u. I was trying to find the second solution, which is u times the known solution. So my second solution for the third time in the last however long you've been looking at these videos is going to be e to the negative 5, 6x times e to the x over 3. And things with the same base, you add their powers, so negative 5, 6 plus a 2, 6 equals e to the negative 3, 6x, which of course is e to the negative 1/2 x. That is my second solution to this very fun second order differential equation with constant coefficients. Whew.